My name is Mama Hasbin bin Sadri, and today I'm giving you an all-access pass to step inside that building. We are going to dive headfirst into the fascinating world of plant morphogenesis and phenology. We will map out exactly how a plant evolved from a humble seed into a complex fruit-bearing powerhouse. And I will show you why mastering this master construction schedule is the absolute ultimate secret to elite crop management and explosive yield in the field. First is morphogenesis, literally meaning the origin of form. Morphogenesis is the active, chaotic, brilliant construction process itself. It is the biological engine that forces generate blank slates to organize themselves into a complex three-dimensional patterns in space. Think of it as the ultimate site supervisor. Without morphogenesis, a growing plant would just be a formless, disorganized lump of tissue. This construction process relies on an intense three-way communication network to decide what to build. And first, it reads internal genetic code to map out the basic body plan. Second, it deploys chemical hormone messages like auxin that travel through tissues telling specific sectors to grow or bend. And third, it reacts to the environment like shifting light or gravity, which literally sculpt the plant's final look. Morphogenesis executes work using three strict rules on the cellular level. The first one, cell division, to multiply the bricks, and two, cell expansion, where fluid trigger pressure blows to cell up like hydraulics run, and the third, the cell differentiation, where generic cells choose their ultimate carrier path, specializing into the protective skill gain, cell skin, or high pressure water pipes. What is phenology? If morphogenesis is the hard construction work, phenology is the project calendar. It tracks the precise timing of these structural changes and the exact moment of seed wakes up, a flower pops, or a leaf drops. This calendar is strictly ruled by nature's alarm clock, daily hours, and accumulated heat, which we track as the growing degree days, or GDD. In agriculture, if you don't know how or your phenology, you are farming blind. Phenology is what gives us precision superpower. It tells us exactly when to blast the field with nitrogen during the vegetative canopy build, and exactly when to hold our water produce ultra-sensitive, make or break flowering windows. It schedules our harvest. Next, the first one is all about breaking ground. Every epic structure needs an immovable foundation, and in our biological world, this project kicked off with germination. The very beginning of the international EBC's scale. Think of the seed as the prepacked, high-tech survival toolkit that starts with an embryo with raw energy reserve. Suddenly, the alarm goes off. Construction begins at the meristem, the plant's active high-intensity construction zone. Morphogenesis fires up its engines. First, cell division through mitosis kicking, where cells furiously clone their DNA, build a brand new cell plate right down the middle, and they multiply and multiply. Then comes cell expansion, where the rigid cells fall loosen up and a massive internal backbone drains in water, creating intense trigger pressure that physically stretches the cell forward like the hydraulic ram. Now we have the primary root and shoot system. The load-bearing pillars of our building look at the internal plant. The xylem acts as a high-pressure water, mains blasting moisture up from the dirt, while phloem acts as the localized power grid, routing energy down to keep the workers fed as we roll into the vegetative phase. The plant starts constructing exterior. It doesn't just show or throw leaves out randomly. It is a precise mathematical pattern called phylogeny. It arranges its leaves at perfect angles along the stem to ensure that every square millimeter catches maximum sunlight, but completely avoiding self-shading. It is building its own state-of-the-art solar grid, optimizing its surface area so the photosynthesis generator can crank out enough glucose to power the next massive expansion. Now, once the structural frame is rock solid, the plant gets the signal to completely shift gear. It enters the reproductive phase. The building stops spending purely on its own height. It completely rewrites its energy budget to invest in more to the next generation. And it all centers around a magnificent structural marvel, a flower. Inside this battle, a biological miracle called double fertilization takes place. This is the ultimate corporate double investment. One sperm cell fused with an egg to build a future plant embryo, while a second sperm fused with solar nucleus to build the endosperm. What is the endosperm? It is a highly secure nutrient-dense storage warehouse built purely to feed that baby plant when it's trapped underground in the dark during its future germination. The moment fertilization hits, morphogenesis tear up the old blueprint and draw a new one. The showy petal drop and ovary tissue undergoes a dramatic swelling transformation, morphing into a fruit. This fruit isn't just a tree, it's a round, armor protective wall and a strategic shipping container designed to blast the ship far away from the current plant so they don't fight over resources. This is a massive logistical shift. The plant aggressively cuts off energy. The new green leaf and shoots 100% of its photosynthetic profit straight into this reproductive structure. Now we have come to the last phase. Every great structure eventually hits its operational limit. This is the downward drop of the plant's growth curve, senescence. As our biological building ages, a harsh reality sets in. The daily cost of maintaining this old faraway leaf start costing more energy than the leaf they actually produce. The main villain here, who? The visual shading. The canopy has grown so widely successful and thick that the lower floor of our building are left in pitch darkness. They stop generating glucose. Instead, they become parasitic energy drains, burning up precious sugar through cellular respiration, while contributing absolutely zero to the business. But plants are master logisticians. Instead of letting the building collapse, they pull off a brilliant controlled decomposition strategy, return recycling, through silencing the plant systematically cuts to sparing lower leaf. It tears down complex molecules, salvages high-value materials like nitrogen and minerals, and pumps them straight back into the mainstream. The roots are the ripening seeds. Once a leaf is completely stripped of the value, the plant triggers abscission, the physical firing of the acid. Cell walls at the base of the leaves leaves them cleanly dissolved in a controlled rate, letting the dead weight drop to the ground, slashing the respiration load, and saving the core organism.